Hello everyone, I'm Ty Seibert with La Jolla Logic, and today I'm going to be discussing CAASI, our Cognitive Autonomous Artificial System Intelligence tool, which is under development on a Small Business Innovative Research Grant sponsored by the Naval Sea Systems Command. La Jolla Logic was founded by our CEO Stacy Infuso in 2011. We've had good continuous growth since then and are now well over 50 people. Everything we do has some aspect of cybersecurity involved. Our typical cyber services, we do secure enterprise architecture design, risk management framework accreditations. We provide NIST 800-171 and CMMC compliance assessments. We have a lot of cross-domain solutions expertise, both in product development and also policy development for DoD. For artificial intelligence and machine learning, we specialize in both supervised and unsupervised machine learning techniques, the development of structured data models, and data warehousing and analytics. We do a lot of secure software engineering, DevSecOps work both for ourselves and our customers. We are primarily an agile software development group. We do cloud architecture development and deployment, and for continuous integration and continuous development, CI/CD work. We do that as part of our DevSecOps work, both internally and externally for our customers. The Navy challenge that led to the development of CAASI was the desire to enhance the speed and accuracy of responding to malicious cyber activities. The primary goal was to provide capabilities for all surface platforms. However, CAASI is appropriate for all networks across surface, subsurface, and shore-based networks, as well as commercial business networks. The initial goal, again, was to reduce response times, as well as to use inference engine technology to adapt to new threats. And as I'll mention in the upcoming slides, we deviated somewhat from the classical inference engine technologies and instead implemented an unsupervised machine learning tool for alerting on detection of anomalous activity. The initial target environment was to use CAASI to monitor a series of industrial control system networks and identify anomalous or malicious activity. The goal was to quickly identify attacks so mitigations could be enacted before actual damage occurs. Although the initial target was for ICS, the CAASI technology is appropriate for all networks regardless of particular activities or missions. So what really is CAASI? CAASI is a tool for performing out-of-band monitoring across network segments, so it isn't necessarily attached to the business portions of the network. It simply watches all of the network traffic as it passes by and identifies activity that is unusual based on all previous activity. As stated earlier, the primary goal for CAASI was to be able to detect unknown methods of attack against unknown vulnerabilities. CAASI uses an unsupervised machine learning approach to accomplish this. The primary difference between supervised and unsupervised machine learning is that with supervised machine learning, you have specific methods of attack that are being looked for. The system gets trained on those particular attacks and then looks for those patterns of behavior on the live network that might indicate an attack. With unsupervised machine learning, the network is observed to create a model of typical network behavior. The system then looks at current network behavior and compares that to the model and looks for activities that are unusual and might indicate some kind of malicious activity. There are a lot of supervised tools that perform quite well at detecting known attacks, and CAASI isn't a competitive capability for those systems, it's a cooperative capability. Both approaches have their own strengths and weaknesses, and together provide a more comprehensive detection ability. There's some attacks that an unsupervised tool just isn't going to find, things like a SQL injection attack, for instance. From a network perspective, that looks like completely normal activity, whereas a supervised machine learning tool might identify that easily. There are also a lot of attacks that can be detected by an unsupervised machine learning tool that a supervised tool likely will not find. Those might be new methods of attack against unknown vulnerabilities, zero-day attacks, worm activities, insider threat behavior, botnet activations, or any other attacks where you don't know specifically what you're looking for. So both approaches have a place in providing an overall detection capability. One of the common downsides of unsupervised machine learning is a potential for high false positive rates. It really doesn't matter how well a system detects anomalies if those detection notices are buried in a pile of alerts that an operator has to sort through. Empirical testing of CAASI on over 2 years worth of real-world data has shown an extremely high detection capability with a potential false positive rate of a handful per year. The longer the system trains, the more accurate it becomes, and training on a couple of months worth of data was sufficient to provide very high detection rates along with very low false positive rates. CAASI observes network traffic and builds a model of what constitutes typical behavior. That model defines attributes of typical connections between software components over whatever particular port a system happens to be using. CAASI has no knowledge of standard ports or protocols. It simply observes all traffic for each packet. It updates the model for that port on that server. So if one system installs software using standard ports and another server uses non-standard ports, that does not impact CAASI's ability to detect anomalous behavior on either system. As I mentioned, CAASI is being developed under a Small Business Innovative Research Grant. It has completed Phase 2 activities, and a Phase 3 contract is currently in the works and will hopefully be awarded within the next month or two. CAASI is currently at TRL 6, and our goal is to bring that to TRL 7 under our next round of funding, along with making further enhancements to system capabilities. We're also looking for transition paths not only to programs of record within DoD, but also within the commercial sector. What are the key features and benefits? Again, unsupervised machine learning allows for detection of malicious activity with no prior knowledge of ports, protocols, methods of attack, or vulnerabilities. It's a very efficient architecture that is capable of rapidly processing large amounts of data and identifying anomalies within that data. Also, the system has the ability to continue learning over time. So as new software or even new versions of software are added or new staff are added to the team and system behaviors change, CAASI evolves along with those patterns of behavior to keep detection high and false positives low. Not only can the system as it currently exists be used for, in addition to the normal detection of malicious activity, for understanding system connectivity and data flows between and among systems, it was designed as a framework rather than a targeted application and utilizes a modular pluggable architecture. This means the actual application of the tool are really only bounded by imagination. With a new ingestion engine and a new analytics engine, rather than detecting nefarious network activity, CAASI could be used for fault prediction for hardware and software, or even something like analyzing X-rays to identify tumors or other abnormalities. It could be used anywhere that identifying unusual things would provide value. Transitioning to the fleet. So our goal is to continue optimizing and enhancing CAASI and to also prioritize integration with other existing capabilities. CAASI currently has a flexible and configurable notification engine that provides sticks and taxi message support, as well as providing a publish and subscribe model, which can be used by any external program. There are a lot of third-party tools that may not be amenable to either of those communication techniques, and we plan to investigate other potential integration pathways to make CAASI analysis and alerts available to the widest practical family of external systems and dashboards. We're also very interested in performing testing and analysis of CAASI within a broad range of platforms and networks, including command and control networks and general purpose business networks. A tool for identifying malicious activity, including insider threat activities, clearly has broad applicability not only across DoD, but across the commercial sector as well. It was designed to easily integrate into existing environments and share analysis results across a broad set of tools, dashboards, or external applications. The unsupervised nature of the tool lends itself to being used in a very broad range of applications beyond just cybersecurity. We plan to continue our relationship with NAVSEA to enhance system capabilities, and we would welcome all opportunities to work with other organizations to apply the technology to new networks and new problem areas. If you have any questions or would like any additional information, please feel free to contact either me or our Vice President, Karina Arishanian. I hope you found the presentation and CAASI to be interesting, and thank you.